Lesson 11.2, Arithmetic Series. Now notice the different term here, series. An arithmetic sequence is a list of numbers. That's a sequence. See, an arithmetic sequence is a list of numbers. An arithmetic series is the sum of that list. So when they say an arithmetic series, they're asking for the sum of the terms of that sequence. There's two formulas I'm going to give you for this. One is, you will use if you know first and last terms. And that will be S sub n, so the series, the sum of n terms, by taking the number of terms, dividing them by 2, and you add up the first term and the last term. A sub n represents the last term. The second formula will be to use if you don't know the last term. And that formula is S sub n, the sum of n terms, number of terms divided by 2 still, and it's 2 times the first term plus n minus 1 times d. A little bit of the first formula we had from the last lesson. Alright, so find the sum of the arithmetic series. Find the sum of the first 20 even numbers beginning with 2. Well, we have 2, but not the last term, so that lends itself to the second one here. So the sum of 20 terms, 20 even numbers, so you have 20, is the first sum of the first 20 even numbers. So 20 numbers, divide by 2, 2 times the first one, which happens to be 2, plus, and here's where our n here is the same as our n here, which is the same as our n here, and that's 20 minus 1 times d. And the difference between even numbers is 2. A little clue there for us. So the sum of the 20 terms is 10 times, we have 4, 20 minus 1 is 19, and we get 4 plus 19 times 2 is 38. And 4 plus 38 is 42 times 10, 420. Okay, we can use the formula for many different things. Find the first term. Okay, so given this statement, that's one of our 2, where S of 31 is this, and D is this, find the first term. So they tell us that the 31st term, or the sum of 31 terms, is this. So we're going to write here, we're going to put down 124,000 equals, there's 31 terms, we don't know a sub 1, again we know 31 terms, and we know the difference. Again, one variable, so we can do it. So we have 124,000 equals 15.5 2a sub 1, and then 31 minus 1 is 30 times 100, 3,000. Okay? So we can divide both sides by 15.5. And we get 8,000 equals 2a sub 1 plus 3,000. Subtract the 3,000. And we get 5,000 equals 2a sub 1 divided by 2, and our first term is 2,500. So using the formula with a different purpose in mind. And the first four terms are the first four terms of an arithmetic series in which the first term is 14, the nth term is 29, and s sub n is 129. I'm going to change this to find the first four terms of an arithmetic series. So we have 14. What are the others? So we're going to use the other equation I gave you earlier on, which is when we know our first and last terms. And I'll write it down below again. And that is s sub n equals number of terms divided by 2, and then we take our first term and add it to our last term. So we know our last, the sum of everything, the sum of n terms is 129. We don't know how many terms that is. So we put over 2. We do know the first term and the last term. Now we need to find n in order for us to do this question. We need to find n to use another formula. So n is what we're looking for first, okay? So here we multiply both sides by 2. We get 258 equals n times, and 14 plus 29 is 43. Divide both sides by 43, and n is 6. So there are 6 terms. Right. 6 terms. Now we need to find the difference so that we can go from there. Okay, so the difference is d. I'm going to go different color here. And we're going to go to this equation. And find d. So a sub n is 29. They told us that. Our first term is 14. They told us that. We know now there are 6 terms, and we don't know d. So subtract 14 from both sides. We get 15 equals 5d. So d is 3. So we would have 14 plus, 17 plus 20 plus 23. And this would be our series. First 4 terms. This ends part A of lesson 11.2.